Here we're looking at section 5.1, the introduction of probability. And in example 1, we have two cases where we want to find the probability of the following experiments. So in probability, I do want to start off by mentioning that there's two types of probabilities we're going to discuss in this class. We're going to talk about empirical probability. Okay, so scrolling up through the handout, you'll see empirical probability being the first method for calculating probability. And empirical probability means typically there was a sampling that occurred, and based on the sampling, you have relative frequencies or probabilities based on that. So for example, here we have 200 individuals, and we asked them for their means of transportation. Those who drive alone, 153 answered this first option. So the relative frequency was 0.765. In chapter 5, relative frequency, we call that probability. Okay. So when it comes to empirical probability, I want you to remember that probabilities can change. If I sample a different 200 individuals, it may not be 153 that answer they drive alone. It could be 154. Even if it changes by 1, the probability to change. That's empirical probability. Typically, a sampling occurs and probabilities can change. For the classical method, this is whenever outcomes are equally likely to occur. So I'm going to show you in example 1 when that happens, but whenever you have outcomes that are equally likely, we use a formula. And that formula, the probability of an event of interest occurring, is the number of ways the event of interest can occur over the number of all possibilities in the experiment. Okay? So let me show you example 1 on how we calculate this type of probability. Okay? So we roll a single fair die. Okay? So a single fair die has 6 sides. Okay? 1, 2, 3, 4, 5, and 6. This question is asking what is the probability of rolling an even number. So if we think about rolling a fair die, all outcomes, all 6 sides are equally likely to occur. So for A, we're dealing with classical method. So let A be the event, roll an even number. Okay? Then the probability that the event of interest occurs has a formula based on the classical method is the number of outcomes in A over the number of outcomes in the sample space. So what I want to do right now is I want to first see how many outcomes are in the event of interest, how many outcomes are in the sample space. So in the sample space, okay, I roll a single fair die. That single fair die has the outcomes 1, 2, 3, 4, 5, and 6. Okay. Notice the sample space, the definition being all possible outcomes in the experiment. 7 is not a possibility if I'm rolling a single fair die. Okay. Decimals and fractions or negatives are not possible when I'm rolling a single fair die. 1 through 6, those are all possibilities in this experiment. But you're not always interested in every single outcome. For example, you win big if you roll an even number. Okay, so we define an event of interest. Okay, and the event of interest is 2, 4, and 6. Okay, now notice we're not including 8, 10, 20, 100 because we're only gathering possible outcomes from the sample space. Okay, so the event of interest must come from the universal set, and that's the sample space. So looking at this formula, the number of outcomes in A, now we can count the outcomes that we have in this set. So we have 1 outcome, 2, and 3 outcomes. And in the sample space, the number in the sample space, here we have 6 total possibilities. Okay, so this outcome will be 0.5. And that's how we use the classical probability, classical formula. In part B, very similar. Okay? Part B is very similar. If a family has 2 children, what is the probability that a random family has 2 girls? Okay, so the first thing we need to do is define the sample space. Okay, what are all possible outcomes for a family having 2 children? Okay, so the sample space possibilities: boy, girl, girl, boy, 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 and girl, girl. Those are the possibilities of having 2 children. But this family, they're not interested in all possibilities. They have an outcome of interest. Okay, so we're going to use capital B to define the event of interest being 2 girls. So this event of interest has what outcome? Remember that these are the only possibilities in the experiment. Well, girl, girl. Then the probability of this family having girl, girl is equal to the number of elements or outcomes in the event of interest over the number of outcomes in the sample space. So once again, we count the number of outcomes in the event of interest. Okay, so 2 children. Here we're looking for girl, girl. We had 1 possible outcome out of how many in the sample space? We had 4 total possibilities. Okay, so here we have 0.25.